Hi, welcome back. Now that we've gained some intuition about uh, a generic function, let's also gain some intuition about limits uh, from graphs of functions. So let's look at this example here. Right now, let's not be concerned with what the actual equation is of the limit, but instead let's ask the question, does this function have a limit at a equals -1? So when we say this limit at a equals -1, what we're saying is let x be equal to -1, what should the function be? Okay, and so if we plugged in -1, if we look at this function, plugging in -1 gives us 1 minus 4 plus 3, which is 0, divided by 0. So we get a 0 divided by 0, and 0 divided by 0 does not give us anything, is not a value. So when we see something 0 over 0, sometimes we call this indeterminate, an indeterminate form. Basically what it is that you can't, there's no value that gives. So when you plug in a value, when you plug in x equals a, and you get 0 over 0, or infinity minus infinity, something that doesn't actually have a value, so 0 over 0, this is telling us that we need to investigate further. So in this case, we see that when we zoom in on a is equal to x is equal to -1, the function value f of x seems to be very close to 2. So really what's happening is there's a hole right here. This function is not defined, so f of x is not defined at x equals 2, but the limit as x approaches 2 of f of x, oops, I'm sorry, it's not that it doesn't, it's not x equals 2. F is not defined at x is equal to -1, but the limit as x approaches -1 of f of x is 2. So that is, as we get closer and closer to -1, as our function gets closer, as our x value gets closer and closer to -1, the function value gets closer and closer to 2. Okay, so that's this first function here. Let's look at this function now. So let's zoom back out. Click this button. If you look at this function, so this is how in Desmos you can define a piecewise defined function. I think it's probably good for us to write down the definition of a piecewise defined function. All right, a piecewise defined function is a function that has a different rule or has different rules on different parts of its domain. So the example here is that f of x is equal to 3 minus x when x is less than 2, and when x is greater than or equal to 2, we have x squared minus 3. Right, so if we zoom out even further, we can see, well, it's kind of hard to see, but this part of the function is a line, and this part of a function is a parabola. So this is our function, and the question is, what's happening at 2? Would we say that the function has a limit at x equals 2? So, question, f of x is defined for x less than 2. It's defined for x is greater than or equal to 2. What is happening at x equals 2? Is there a value that the function should have there? Okay, and if we look at this, if we zoom in here, even though this function is coming down here with a negative slope, and even though this function is going up here with a positive slope, it sure looks like this function makes, like, the value of this function is the same from both sides. So no matter how close we get from both sides, it looks like it makes sense what the function is from the left and what the function is from the right. So it looks like the limit as x approaches 2 is, and the function value is 1. The limit as x approaches 2 of f of x is positive 1. So we will write this as the LIM, limit as x goes to 2 of f of x is equal to 1. So we're going to use this terminology, this notation, to write down that this function does have a limit. As you get closer and closer to 2, the function value gets closer and closer to 1. All right, let's go on to the next one. The next one, let's go zoom out again. Okay, so now we're looking at a different piecewise defined function. Let's look at the piecewise defined function. So maybe we'll call it g of x. And when x is less than negative 4, we get sine of x plus 4. And when x is greater than or equal to negative 4, we get negative 1/2 x. So this is a different piecewise defined function. And the question is, does it have a limit when x goes to negative 4? All right, so does g of x have a limit as x goes to 4? Sorry, negative 4. Now this should feel a lot like the example we had from class, in which you have a function that was negative 1 and then jumps to positive 1. So this, if we look at this function, when you approach negative 4 from the left-hand side, the function value is 0. But when you approach from the right-hand side, from the positive side, the function value is 2. And so what we're seeing here is that there are two different values that it looks like g of x should be. One from the left, one from the right. Okay, and when we're talking about the left and we're talking about the right, I actually like to think of them a little bit differently. I like to think of the left as the negative side, and the one on the right is from the positive side. So if we look at -4 and we look at from the left side, the function values do seem to give an answer for what the function should be, but the answer there is different from the answer on the right-hand side. So we'll say that the limit as x approaches -4 does not exist. The limit of f of x, or g of x we called it. As x approaches -4 does not exist. And we'll write the limit as x goes to -4 of g of x dne. You may see dne places, does not exist. You can also write out does not exist, also a good thing to do. Does not exist. And but what we would say is that maybe the limit on the left and the limit on the right exist. So instead, we might say that the one-sided limits exist. That is, the limit as x approaches -4 on the negative side of g of x is equal to 0, and the limit as x approaches -4 on the positive side of g of x is equal to 2. So these are one-sided limits. This is the left side, and this is the right side. And we denote these by these little minus and plus signs on our numbers. Okay, so this is another example. This has a jump from the left side to the right side. All right, let's look at this another example. So here's another example. Here we have sine of x over x, and we want to know what is the limit as x goes to 0 of this. Does the limit exist? Now we look at this picture, and if we look at this picture, we zoom in. The function sure does look like the limit exists. Looks like it. Right? We know that sine of 0 over 0 is equal to 0 over 0. It's indeterminate. So f of 0 is undefined. But zooming in on the graph shows that the limit as x goes to 0 of sine of x over x is equal to 1. And that's something that we'll be able to prove. All right, and the last example that we have here is the sine of 1 over x. And this is the example very similar to what we saw last time. So sine, that's a little bit too light. So sine of x over x, oops, sorry, sine of 1 over x, this function oscillates. So it oscillates infinitely often as x approaches 0. And so again, in this case, we'll say that the limit as x goes to 0 of sine of 1 over x does not exist. Alright, so that's getting some intuition about what these pictures look like and getting the intuition about limits from a graphical point of view. In the next video, I will talk about uh, the writing down in words a little bit more carefully the concept of a limit and what we can learn from there. Alright, see you soon.